Solidity contract development. First use case, the item. The checklist. We will write a Solidity smart contract capable of representing an item. Now, the contract will store the details of an item such as name, price, and owner. It should have the functionality to put the item for sale, buy the item using either, and finally, the functionality to retrieve data related to the item, including name, price, current owner, and other buyers who were once in possession of the item. Let us start with creating our smart contract in the Remix IDE. Create a new file. Let us name it uc1.sol. Start with Pragma. Select the Pragma from the dropdown and get the starting template. Replace version with 0.8.20. Create a contract named item and define its body. Next, create a struct named item data. Now the struct is used to group together multiple data types to create a custom data type. So we will group name of the type string, price of the type uint8, and a boolean named sold. So basically, name of our item, its price, and a flag to show if it has been sold or not. Now using this struct item data, I can create a variable named the item, which will have the members, name, price, and sold. Next, we'll create a variable of the type address named owner to represent the item's owner. We'll be storing the address of the owner in this variable, which will have the visibility public. This means anyone can access the variable. Also, the compiler will create a getter function for this variable. Then we will create a dynamic array of the type address named buyers to store all the buyers who once possessed the item. Next, we'll define a constructor. Now, a constructor is a special function that is executed at the time of contract deployment. It cannot be executed once the contract is deployed. For example, if we want to set some variable value when deploying the contract, we can do that inside the constructor. For this contract, we can set the item's name by receiving it from the user and setting the owner variable to the account's address that deploys the contract using the message.sender global variable. Now the message.sender represents the account's address that initiated the current function call or the transaction, in our case, the contract deployment transaction. Next, we'll create a function named putOnSale, which will have the input parameters needed for the sale, the item's price. This will be a public function. In its body, we'll store the price to the item variable. The price will be in either. We will also set the sold member variable to false. The default value of sold is false, but we are setting it to false so we can use the same function to put this item on sale later. Next, we'll create a function toWeigh, which will take in an input parameter of the type uint256 named _either. This function will be tagged with internal and pure keywords. Internal means the function can only be accessed by the contract or its child contract. Pure means the function does not interact with any state variables. Next, we'll define its return parameter, which is of the type uint256. Next, within the body, we will convert the input to weigh and return the converted value. So one either in weigh is 1 followed by 18 zeros. So we do the multiplication and return the value. Inside the EVM or contract, the either is represented as weigh. So we created this conversion function. Next, we will create a public function named buyItem. It will be tagged with the keyword payable, which means the function can accept either along with the function call. First, we will check if the amount of the either sent along with the function call is greater than the price of the item. We can retrieve the amount of the either sent along with the function call using the global variable named message.value. The message.value will be in weigh, and our price will be in either. Therefore, we will divide the message.value by one either to convert it to either. Either is another global variable that will return the prefix value in weigh, which means one either is 1 followed by 18 zeros. Then, for the true part of if, we will set the owner to the new address and put the item sold flag to true. This means the purchase is complete and the owner has been changed. We'll also push the buyer to the buyer's dynamic array using the push member function. Also, if the buyer sent more than enough either, we'll send it back to the buyer. To do this, we'll find the extra money by deducting the price from the message.value. As the message.value is in way, we'll also convert our price to way using the function we defined earlier. Okay, if there is a balance after the deduction, we will return it. To do so, we will convert message.sender to a payable address type, which will have the member function transfer. We can use the transfer function to send either back to the sender. Now, a quick note. When we send either along with the transaction, the either is stored in the contract address balance, and the transfer function is used to transfer either from the contract address balance. Next, we'll create a function named getItemData to get the data related to the item. It will be public view and have three return parameters: the item name, price, and whether it has been sold. Then we'll have another function named getBuyers, which will return the number of buyers and the list of all buyers. For the count, we can use the length member function of the dynamic array type. Now let us compile the contract, open the deployment tab, expand the deploy section, and fill in the name of the item. Let's say we'll sell a pen. So enter the pen and press transact. Now the deployed address starts with 0x5b3. Now we can check the item data and the owner data. So it's correct. The buyer list is empty now. Next, execute put on sale with price 4. We can get the data again and see the price has been updated. Let us change the account. Enter the amount in the value field, say 5, and select either from dropdown. Now, execute buy item and recheck the data. The owner is updated and the book details show that the book is sold. We can put it on sale again, say 5 ether. Get the data again. We can see the price has been updated and the flag now shows that the item is not sold. Also, we can see the associated buyer from the buyer's list. So that's it. Thank you.